Hey y'all! Well, we're back to the R300. This is one of the two that viewers had sent over to me. This was the one with the early style power supply. Both of these amps we fixed the power supply, but then, as you saw in the video, we ran into issues with the output transformers. And we temporarily put a EdCore 3.5K 15 watt output transformer, and that fixed that issue. And then I did a video about getting the really nice 30 watt ISO Tango transformer and putting it in my personal 300B DIY build that we've showcased on the channel. So I talked to this customer, or guy that owns this amp, and he really didn't want to drop $1,000 in output transformers. But he wanted to go a step up from these little 15 watt EdCores, which I totally understand. And while they would have worked much better than the factory ones, we discussed the different options, and I've used these Hashimoto EI-Core output transformers. We used it on my 47 Globe tube amp. Let me pull these tubes out so you can get a little better view of the output transformer. And this is a 20 watt unit. It's a HC-203U, and it's got multiple taps. We're using the full range of the core, going with 3.5K, which is ideal, I feel like, on these multi-tap transformers. And this one also has a 4 ohm, 8 ohm, and 16 ohm tap, so we can hook the taps up just like they were with the factory ones. You know, one thing, mounting these isn't as straightforward as it would be with those big ISO Tangos. Had another viewer that wrote me, and I helped walk him through installing a pair of those on his R300. The reason why I thought it made sense for that amp is he's potentially in the future going to DIY build my amp, the budget DIY 300B amp, which I think is a quality circuit that is worthy of that quality of iron. This has got issues, and you'll see in this video the problems that the front end of this amp has on actually driving a 300B tube. And anyway, this looked like a good compromise and a nice price point for this style or this kind of level of amp. And in this video, I'm going to show you testing this versus this, and to show you what a huge upgrade it is. And then in the following video, I'm going to show you swapping out this can for this type of transformer, and how I undid the headphone jack wiring and did the ground stuff like we did on the R8. So let's get to testing this transformer. Okay, so let's do some audio analyzer suite testing on these two transformers and see what we got for our trouble. This is the original transformer, and we're using the Willsenton supplied tubes. Yes, we're going to do a tube swap here later in the video, but for now, this is the way it comes from Willsenton. You can see the distortion down here at the lower power levels is fine. It goes past 1% at 3 watts. Then here at 6 watts, it starts climbing pretty steeply. And I have a feeling that somewhere right in here is where the amp starts clipping. So we're going to call this a 6.5 watt output. So the next thing we want to look at is the frequency response. Again, this is what we were trying to fix. This super nasty, it's basically headed towards a short at 15K or 20K. It's, you know, definitely not what you want to see on a frequency response on a tube amplifier. And, you know, we start looking here at even 4K, it's starting to roll off, and by 8K, you've got 1.5 dBs of roll off, and by 10K, there's 2 dBs, and obviously here at 15K, we got 6 dBs of roll off, so that's not ideal. The last thing we're going to look at is the scope patterns. So here's the sine wave at 1K, which is pretty much where we test stuff, and this is at 2 volts RMS in, and it looks nice. Let's go ahead and double this, and this is probably where we're going to start seeing clipping. And yes, you can see it's actually asymmetrically clipping, which isn't ideal. Let's see how far it has to go up before it starts clipping on both ends of the sine wave. Okay, 0.5 volt RMS in, we are clipping on both sides. So that's, even though it starts clipping a little sooner on this lower trace, I'm not too worried about that. That's not horrible. But let's see if we can find the point where the clipping stops. So let's try 0.35 RMS in, which is where I'm suspecting, yeah, we're not clipping anymore. And if we come back here and look at this chart here, you can see up here in this upper corner, it's showing the input voltage. And once you get to 0.35 RMS in, the distortion line turns straight up. And so that's when the amp starts clipping. So again, and I know some people argued about this with me, but I'm not going to say that, yeah, 5% distortion is the power level. And I know some people rate amplifiers by how much power they make at 5% distortion. Every amplifier that I've tested on my channel, I've gone by how much power is it making before it starts clipping. And to be fair, every amplifier needs to be judged on that same criteria. And so for this amp, it's right there at 6.537 watts is the onset of clipping, or the most power that it makes before it starts clipping. So for Skunky's rating, this is a 6.5 watt amp. So let's look at the scope pattern again, and let's take a look at the square waves, because that was another issue that we had with the original transformers. And even at 1K, this is a pretty nasty square wave. It's got a little dipsy doodle here, and it goes up and it overshoots, which a little overshoot's not a big deal to me. And then it flattens out pretty quickly. There's no oscillation. So while this isn't really ideal, the amplifier is not struggling right here. So let's look at the 100 hertz, and this looks fairly normal. You're going to see it slope off like this, because this is like the lower frequencies, these are the higher frequencies. It does have this little spike here at the start, which I don't normally see, but I'm not going to freak out about that. But here's the one that was really nasty looking, and this is the 10K. And just to be fair, we'll pull it again at half power, just so people can't say, oh, well, you're right at max power before clipping. Of course it's doing that. It does the same thing. It's got this crazy dipsy doodle here as it comes into the higher frequencies, and then it rolls up and does that weird, yeah, that doesn't even resemble a square wave. So let's see how this Hashimoto transformer compares. And I learned that the factory output transformer is so brutally bad that it will impact the other channel if you try to drive both channels at the same time. So we're switching the input signal, we're using mono in, switching to the other channel, and we're testing one channel at a time so that the bad output transformer doesn't show up on the graph for the new one. So here's our THD versus power. Not expecting to see a huge difference here. Looks like it might be a little lower. You can hear the amp singing along as it's doing this. So again, right here at 6.5 watts, turns up. Distortion may be a tad lower, but it's very similar. And I think that's more of a function of the output tubes and the driver tubes and just the circuit itself, more so than the output transformers. And honestly, this curve looks like you would expect to see on a 300B amp with 0 negative feedback. And the only way that this amp gets this low in the distortion numbers is they're applying quite a bit of negative feedback, which is telling me there's something wrong with the front end circuit design. But we've talked about that before. That's going to be a much more in-depth later project with the other R300 I have here of figuring out what's wrong with the front end design. But let's look at the frequency response pull. Again, this is the factory one with this weird mess up here at high frequency. And let's see how this Hashimoto transformer performs. Looks like it flattens out right at 20 Hertz, so we're not losing anything on the low end. But then look how flat it is on the top end. Because right here, if you look at these numbers, look at this left number up here. You can see that's basically 0 dB. When you get down to 20 Hertz, we're a quarter of a dB down, and then picks up a tenth of a percent, like right up in here, which again, that's not going to even be audible. But here at 10K, it hasn't dropped at all. And even out here at 20K, we're only down 0.4 dBs. So this Hashimoto HC-203U totally fixes the frequency response problem. So let's come in here and look at the scope pattern. And we've already determined where the clipping point is, so we're going to just leave this at 0.2 RMS. Here it is at 0.2 RMS. Let's see if the clipping point is the same. Yep, it's clipping down here at the bottom at 0.4, and then 0.35. It's not clipping, so we got the same power and clipping point and all of that. The transformer didn't change that, which is good. I mean, it would have been nice if it had cleaned that up a little bit, but it didn't make it worse, so there's not an issue there. So here's back to 0.2 in. Let's look at the square wave, and look at that. The little dipsy doodle here in the middle of the square wave at 1K is gone. Got a little bit of ringing here, but then it quickly stops. A little bit of overshoot right there is not an issue, but again, that huge dipsy doodle we were seeing earlier that looks like this is now gone. So let's take a look at 100 Hertz, see what this looks like. And again, that giant ring that we saw at the start of the 100 Hertz square wave is also gone now. So here's the one I'm really curious what it looks like is, what does the 10K one look like? Because that was the one that was just particularly nasty looking. And there we go. I don't know about you, but that looks like a square wave. It's definitely got some ringing here, but it doesn't just continue on. So I'm not super concerned about that, but that looks so much better than what we saw out of the factory transformer. I may come in and try adding, 10 PF at first, then see where that gets us on this oscillation or this little bit of ringing up here on the upper frequency. But yeah, this transformer fixed that whole wonky 10K square wave issue that we were seeing before. So again, this may take a little bit of feedback tuning to get this, where it's really going to look clean. And I'll do that in a future video. We'll kind of do a little fine tuning on this amp, but yeah, huge, huge, huge difference. And honestly, guys, I'm like this compared to this is night and day. So the next thing I want to do real quick is I'm going to pop in the Western Electric 300B tubes and the other front end tubes. Actually, I'm just going to do the Western Electric tube on the output and see what that does for our THD versus power, and see if that cleans this up a little bit. And let's go do that. So we have a pair of real Western Electric 300B tubes in the amp and biased up. These are these $1,500 a pair premium tubes. So let's see how they perform in this amp. And we can see the distortion is down here nice and low. See, this is our 1 watt point, and so 0.3% distortion as it go past 1 watt. Still staying pretty low here. We're under 1% distortion at 3 watts. But we can see it does seem to be turning up a little sooner in this range. Here we got 5 watts under 2%, but then it starts turning up pretty quickly. And honestly, it looks like the amp is starting to clip here at just a little over 5 watts with these real 300B Western Electric tubes. What we've probably got going on is, given that these are like the real OG type 300B tubes, they've got the rated Miller capacitance that these tubes are known for, and these are really hard tubes to drive. And the front end of this Willsenton amp just is not able to supply enough current to, or oomph, whatever you want to call it, to actually drive a real pair of 300B tubes. So before we get into looking at that, let's make a note here that around 3.2 volts input, it's on the upper right of the screen, is where this line starts turning up quicker. Let's see what it does with the other output transformer and see if we have the same thing going on with the Hashimoto. Here's our 3.5 watts at 1%. But then the same point here, just over 5 watts at 0.3 volts or 0.33 volts RMS is where it turns skyward. So over here on the scope, we got 0.35 volts RMS, and we can see with these tubes, the front end's clipping. It's not able to really drive these tubes to full power. And so I have a feeling if we put in 0.32 volts, no clipping, which is what we're seeing here, that once it goes past this 0.32 volt kind of point here at 2% distortion, it just ramps up. And so this distortion we're seeing here at the higher power levels is not the tube, it's not the output transformer, it's that the front end of this amp is just not capable of driving a 300B tube. And these tubes were meant to be driven with a pentode, or like in my amp we used a cascode, which is a pseudo pentode, and something like a 6SL7 or a 12AX7, one of these high gain tubes, just does not have enough drive to be driving a 300B tube. And they used a front end that would have been fine to drive something like a KT88 single-ended amp, but it's not going to drive a 300B tube to full power. Now, if you're listening down in this range here, 1 to 3 watts, it's going to be fine. Even up to this 4 watt range, it's going to be fine. But you can see right here, it starts clipping at 5 watts. And that's just a function of the front end design. So let's take a look at the square waves with these Western Electric tubes. Ringing looks similar. It's right there. Let's go ahead and do this at 0.2 volts. So that's what we did on the other one. It's got the similar little ringing. Obviously it doesn't have the big dipsy doodle that we see when we switch over to the factory transformer. As you can see, this is a mess. It goes burp, burp, and then jumps up here and does that little thing. When you go to the Hashimoto transformer, all that disappears. So let's look at the low frequency with these Western Electric tubes. That looks good. Like I said, just a little slight overshoot there right at the start. Doesn't bother me at all. And then let's see what the 10K looks like. See if we still have the same kind of ringing that I might need to tune out of the feedback loop using these Western Electric tubes. Yeah, need to do a little tuning here. I think a small bit of capacitance might only take like 10 PF will, tamp down this oscillation and make this just kind of roll like that. So probably going to do that, because the next thing I'm going to do is we're going to go ahead and put the transformer on the other channel. And then I may do the feedback loop with a capacitor on one channel and not on the other, and go listen to them so I can, A/B them and see and make sure that adding that little bit of capacitance to the feedback loop doesn't negatively impact the sound of the amp. But yeah, I'm liking what I'm seeing here with the THD versus power with these Western Electric tubes. And they're just harder to drive tubes, and it's just showcasing that the front end of this R300 just really isn't able to drive a 300B tube to full power without clipping. So let me put in a set of new old stock front end tubes just to make sure that it's not something with these Russian tubes that they deliver with the amp. But these OTK tubes are normally pretty decent tubes, and I'll be shocked if that cleans up this problem. But hey, till you try it, you don't know. So let me swap those tubes in and see what that does. So as you can see from this testing, huge upgrade, and it totally fixes all the issues that this factory output transformer has. Honestly, kind of shocked that nobody caught this before they went out in production, but hey, here we are. Now, as far as this new black upgraded R300 they're selling that has 5AR4 tubes after my recommendation, they say they've upgraded the output transformers. I have no idea. I haven't seen one. I haven't tested one. When I was still talking with Willsenton, I asked them, hey, y'all are upset about me posting these videos about the problems with your R300. Said, hey, send me your newest one, and if it tests good, like the fixed, what I call the Mark II R8, if y'all have fixed this thing, hey, you'll get a great review. And they cut off all communication. So I have no idea what they're doing. And so if one of you has one of those newer ones and wanted to send it to me to test, I'd be willing to do that. But obviously you'd have to pay the shipping back and forth, which is going to be a lot of money. So, or if somebody local has one. But anyway, if you got one of these earlier versions, after you fix the power supply, a pair of these Hashimoto output transformers are going to fix the other problem that I saw with this amp, but it's still going to have this, what I'm calling a weak front end that is just not capable of driving a 300B tube to full power without clipping. So you have to live with that. And Woody, the guy that owns this one, he's got some Clips Forte speakers. He's probably going to be using the 1 to 3 watt range, and have a little bit of headroom there. And this is probably going to work fine for him. In the next video, I'm going to show you how to replace this big can with one of these, and how to drill the holes, how to do the wiring, and then what I did with the headphone jack wiring to clean up the grounding in this amp like we did in the R8. So, Hope you're enjoying this content. If you are, please subscribe to the channel. Please like the video. Thanks to all you Patreon folks and also you folks that donate to the website, and especially folks that let me use your amp for these types of demos and content for the channel, because I think y'all will enjoy learning how to do hi-fi on a budget. And until the next video, have a nice day.